Very good. Well, now we're ready to fill the cell with one of our gases to do a sample measurement. We'll start with carbon monoxide. Notice in this gas handling system, there are a set of valves that connect my cell to either the carbon monoxide tank, the carbon dioxide tank, or the vacuum pump. And this meter reads the pressure in the gas cell, which right now is vacuum, or minus 28 inches of mercury. Let's go ahead. We're going to, we're going to seal off the cell from the vacuum pump, and we'll open the cell to the carbon monoxide. 1 second. There we go. And it works well if we fill the cell to about 1/2 an atmosphere. We're done. Okay. The display here is showing what the signal looks like right now. And remember, this is a Fourier transform spectrometer. It's a little bit weird because this is intensity as a function of moving mirror position in the interferometer. There's a peak here at what's called zero delay. And then when you get away from the 0 point where all the wavelengths interfere constructively, different wavelengths will interfere destructively and the pattern will just smear out. Okay? Of course, this is impossible to interpret by eye. However, we can go and have the system show us the Fourier transform of that little snippet of data. Here we are. And let me blow that up a little bit so we can see it more easily. And blow it up a little bit so it's easier to see again. And you can see what it looks like. Maybe you remember from the experiment you did in modern physics, this curve here, the broad outline is due to the source, which is a hot black body. So this is a black body curve. By the way, low frequency is on this side, high frequency is on that side. Within that, we see two strong absorption bands. One is due to carbon monoxide, and the other is due to carbon dioxide, the two things that we're going to investigate today. The carbon monoxide is the gas in our cell. The carbon dioxide that we see right now is extraneous. That is, we didn't put it into the cell on purpose, but it seems to be there nonetheless. Or it might be a little bit of carbon dioxide, which is present inside of the spectrometer. It doesn't matter. And so for this experiment, we'll focus on the carbon monoxide. The data that we're going to take will look like this, but it will be much, much higher spectral resolution. So let's go ahead and get started. Okay, we're ready to start the acquisition. I'll say okay, and off it goes. This will take a little while, and lucky you, you don't have to sit and watch the experiment while it runs. We'll just wait for 1 minute while it takes the first scan, and then we'll let it go off and complete. Okay, and here's what the spectrum looks like now. We're almost done doing our signal averaging to get good signal to noise, but it won't really change. You can see now strong bands of absorption lines throughout the spectrum. But actually only one of these is going to turn out to come from the gases of interest to us. The others are water vapor and carbon dioxide.